We will be looking at how elements in series and parallel act in AC circuits in comparison to DC circuits. In DC circuits, calculating the resistance in series is just the sum of all resistors. Calculating resistance with parallel elements is just the sum of the inverse of resistors. In the AC circuits, there are other elements involved such as inductors and capacitors. Much like resistance in DC circuits, inductors and capacitors are both calculated in the same manner, with elements in series being the summation of two and parallel circuits being the inverse of the summation. This is an RLC circuit. There are two inductors in series with a lone resistor and two capacitors in parallel. You are to find the total impedance of the circuit. In order to do this, you must find the reactance and inductors and capacitors. In an inductor, reactance is equal to 2 pi times the frequency and the inductance in henries. The answer would be in ohms. Make sure to use SI units. In a capacitor, reactance is equal to 1 over 2 pi times the frequency of the AC input times the capacitance in farads. This answer will also be in ohms. Since the reactance values of the inductors are in series, simply add the reactance in series. For the reactance of the capacitors, simply add the inverse of the reactance values. Total reactance is found by subtracting these values. Having this in absolute values will remove any potential negatives. Since the circuit has parallel components, impedance is equal to the resistance plus J times the total reactance. Thank you for watching!